Sorry for the chaos here this morning. Things are a little goofy with a doctor's appointment. We're starting on the back of the sheet right now that has the giraffe on the front, the one that says solving for y. We're going to do this a little bit backwards. So the video I have on here is going to start on the back of the sheet, go to the front, and then we're going to go to the sheet that's called functions and get you going from there. So here goes.
It's just like what we just got done doing for the last three problems. Now, we're going to change the directions though, because this says write its slope-intercept form. Intercept. We're going to keep doing what we've been doing. Now, here's how this is going to work. I want to take a look. I'll look at 10. Maybe we'll go over 2 here. So when I'm doing these, I need the x-intercept, I need the y, I need the 2 points. So again, if I'm looking for x, I'll cover up y, and I solve that equation. I cover up y, what I see left is I see 2x on the left, and I see 1 on the right. What's my one step to get x by itself? Okay, just divide by 2. You're like, wait a minute though, that's like a decimal, that's like 1/2, or it's like 0.5. What's up with that? That's not a big deal, because what I can look at, okay, here's my y-axis, here's my x, okay, x is 0.5, it's just between 0 and 1. So I can still do it, doesn't have to be perfect on the decimal, but I can get the approximate area. For my y-intercept, I cover up x. Oh, y equals 1, that one's done already. Y equals 1. Draw my line through, and if I did it right, it should go through a letter. So this one went through N. Okay. And that's basically what we're going to do on this whole part. Now I'm going to do 11-2. Then I'm going to start introducing something to you a little bit today before we actually do a lesson on it. So one more time. X-intercept. You can just try to write x and y. That's fine. Okay. X-intercept. Cover up y. Like, all right, negative 3x equals negative 4. You're kind of starting to catch on here. It's always that same one step. What's my one step here to get x by itself? Okay, divide by negative 3. But again, don't let the fact that you get a decimal mess you up. 3. I can do 1.33. Just going to remark my axes here. So 1.33 is a little more than 1. My dot on my x-axis. Once I put my dot, I switch. I cover up the x. I write what I see, 2y equals negative 4, and I do the same one step. I divide. Y is negative 2. Down. All line, sweet, goes through a letter, T. So that's all we're doing. X-intercept, we cover up the y. Y-intercept, we cover up the x. Make money from office tax and advertising for them now. So that's what we're looking at here on the back. On the front side, you're like, ooh, this looks a little different. Solve for y. What? In other words, get y on a side by itself. And that's what's going to work the whole way down on this one. So for instance, in number 1, if I want to get y by itself, how do I get the 2x out of there? Minus it. And sometimes it'll be as simple as one step. Now here's where I got to be careful though. When I come over here, this has x, this doesn't. I can't put these together and call this 10x. That doesn't work. I put the x part first, then the number. And I need to do it that way, because this is going to be something we're going to work on here in a few days called slope-intercept form, where it's y equals, and then the x, and then the number. So I'm going to bounce around a little here. I want to take a look at 3, I want to take a look at 9, and we might have another one of those two. So on number 3, my first job is to get the 2y alone. How do I dump x? Minus it, it's positive, good. We're like, okay, so that goes away. And if I see no number in front of my x, I assume there's a 1. And just like on the first one, this has x, this doesn't. I can't combine them. They can hang out on the same side of the equation, but they can't be together. But this time I'm not quite done yet, because y is not totally alone. One step left. Okay, divide by 2. Oh man, video noises again that I shouldn't be hearing. Okay, if it stays in a fraction form and doesn't reduce, just leave it as a fraction. Try to stay away from decimals here, so I really don't want to see 0.5x. But 8 divided by 2 is 4, and y is alone. So again, don't let anything kind of mess with you here. It's going to be the same step or 2 steps for every single one. One last one here, 9, unless somebody finds one they want me to play with. Ooh, I see. I want to play with. I want to play number 9 at the bottom, too. So number 9 up here at the top, just keep telling yourself, all for y, must get y alone. Positive 5x, just like we did on number 3, we're going to minus that. Then I got to give myself one more reminder. Oh yeah, I can't combine these. This is not 5x. Separate, kind of work through them that way. And then my last step will always be to divide if I need it. And we just kind of get to reinforce here. If I punch 5 divided by 2 in my calculator, I get a decimal. I don't want no decimal. So I'm just going to rewrite it. Ooh, but what's 10 divided by 2? Okay, negative 5. Okay, y is by itself, I'm done. So at most it's going to be 2 steps. Sometimes it's only going to be 1. Except for the one exception, of course. Sure, this one? Okay. Want to get that by itself. How do I get 4x out of there? Not divided quite yet. No, we're not going to divide it. Remember, the only time we divide is whatever number's with y. Okay, let's chat about a couple things here. Let's finish up this one, and then I'm going to have a different start to the next one. Let's see if that works better for you. So the x and the 9 can hang out on the same side, but they can't be together. And then since I still have that negative 1 that's attached to my y, I'm going to divide everything by that number. Because I have to get y positive and by itself. Negative divided by negative, and I'm going to do another one here too in a minute, is positive. Positive is y equals 4x minus 9. My whole job here is to get y alone. So let me kind of put it this way. Let me pull this down for a second. When you're solving for y, 2 steps. 1, I'm either going to add or subtract my x term. So if there's an x there with the y, I got to plus or minus that out of there. Perfect. And then I'm going to divide by whatever number's in front of y. It's always those 2 steps. That's not going to change on me. Okay? But like I said, there's one exception. Just one. Way at the bottom of this page, on the second number 9 on this side. And then again, if there's some other ones you want to take a peek at, I'll be happy to do it for you. You're like, ooh, okay, here's my y, but now I got x's and numbers over here. What's the deal? Well, I got one extra step I got to do. I got to get the number to the other side, because I don't want it hanging out with y. Right, now I can do my steps. Now I can, in this case, minus my x out of there. Yep, and I just got to keep reminding myself, I can't combine the x with the part that doesn't have an x. They don't quite mingle. And if I divide by 2, when I go to the calculator, if I get a decimal, I'm just leaving it. So I'm leaving the negative 7/2. I'm leaving the 3/2. And I'm done. So that's what I'm up to on this half. Get the y term by itself, and if there's a number with y, I divide by that. That's never, never, ever going to change. Any other ones that look kind of ink that we want to take a peek at here? I'm absolutely willing. No, it was low. Okay. Again.
All right. We are now more enlivened today, talking a little bit about the functions sheet, the other sheet that you picked up today. And I know it's been a little while since we've done this, so I want to make sure that we remember how this all works. To remember if a relation is a function graphically, we're going to draw a vertical line. And again, a vertical line is one that goes up and down like this. And see if it crosses more than one point. If it crosses more than one point, it's not a function anymore. It doesn't pass the vertical line test. If it's okay, then that works all right for us. So like for instance, when we're doing number 1, and again, I can do it anywhere along here. So let's say I choose here. Draw my vertical line in. I see it crosses the actual graph part here, my actual line, one time. So this would be a function. However, when I go to the next one, I start to notice, well, wait a minute. If I choose to draw my line right here, it goes through 2 points. Anything greater than 1 point, when I draw my vertical line, is going to be no. So if you can find a place somewhere in your graph where it's more than 1, that's the place where you draw your line and you say no. If I can go everywhere through my graph, and everywhere I'm going through, I'm only seeing 1 point that it crosses, and there's none. 1, 1, 1, 1. Okay, that's going to be a yes. So that's how we figure it out graphically. If we're figuring it out with numbers, do any x values repeat? Okay, stress on x values. I look at my x's. If they're all different, it's a function. If I start looking at my x and say, oops, those x's are the same, then it's no. Okay? That's all there is to it with the points. Nothing too shabby. Now I get down to the bottom. Now this is a little bit different. And we're not really going to worry about this right now because we haven't gotten into our discussion with slope-intercept and some of those other things yet. Okay, so for right now, I know this is just going to break your hearts. We're going to whack 11 through 16 here for right now. Just because we haven't had a chance to talk about it quite yet, and I want to be here when I can answer questions to be able to do that part. And then finally at the bottom, they give us 2 functions, f, which is this, and g, which is this, and we're going to plug the numbers in. So like for instance, it says f of 2. It means I'm going to use the 2x minus 6, but everywhere that there's an x, I'm going to replace it with 2. And that's all this means. So I'm going to replace the x and just the x with 2, and then I'm going to find the answer to what's left. You're like, but wait a minute. They put like fractions and stuff in here. How am I going to deal with that? Not hard. We're going to go ahead, we're going to pull our calculator up. Because as we've said before, if you can get things set up right and you need the calculator to help you out a little bit, there is absolutely no shame in that. Let's find one that's going to be tricky though. Ooh, 22. Let me move this over here. All right. So g of x is that. So what I'm going to do is every place I see an x, I'm going to replace it with negative 1/3. Notice nothing else changes. I'm just literally taking out the x. It doesn't mean it's 1/3 x. You literally are substituting the negative 1/3 in for x. Now when we're doing the fractions on the calculator, and we've done this before, notice over here I have parentheses, and you need them too. So there's my negative 1/3 minus 2 times negative 1/3 squared. Now, I do not want to see the answer this way. Every calculator basically I see anymore has a fraction button. So if you get a funky decimal like this, I want you to hit the math button right underneath alpha or whatever your fraction button is and enter twice. That's what I want to see. So see, no harm here as long as I just use the tools that are available to me. But I have to pay attention to the letter in front. So 17, 18, and 19 all are getting done with, this is my function. 20 through 22 are all being done with, that is my function, and I'm plugging my x in, okay? So hopefully with all the examples we've done here, you can get these knocked out and set. If you still hadn't turned in homework check 11 from last week, maybe you got a little extra time here, you can get that done. I will have all of your quizzes and other homework check things back to you tomorrow, and we'll see you then.